All right, ladies and gentlemen. Today we're going to continue our chemistry discussion by talking about a couple of models of the atom. Now, when we went through our history, one of the things we talked about is understanding how scientists came to know what protons were, where they were located, what neutrons were, where they were located, and what electrons were, and where they were located. And this specific combination of protons, neutrons, and electrons actually leads to the unique properties that all atoms have. So, to understand and discuss the locations of electrons in an atom, we have a couple of models that we use. It's a very impractical thing to actually try to draw where electrons actually are, because it's like a specific shape in three-dimensional space, and it's a plot of likely positions for the electron to be. And so we use a diagram very similar to what you see in front of you to sort of demonstrate how electrons are positioned around the atom. What we have here in this diagram are what's known as energy levels. Okay, and atoms have multiple energy levels. All right, the energy levels kind of go farther from the nucleus. All right, so the farther you are from the nucleus, the higher the energy level. And there's a lot of in places that electrons can be within those energy levels. There's actually different shapes within the energy levels themselves. For right now, we're going to deal with only a very basic thing. The other key idea is no matter what, the last energy level is known as the valence shell. Okay? So here I have aluminum. All right? So aluminum has 13 protons. And you can see the 13 protons right here. And aluminum, if it has 13 protons, therefore has 13 electrons to start with. So 13 protons we can just write in the middle of the atom. But when it comes to electrons, we have to position them appropriately. So what we do is we use these rings to show that they are energy levels. Okay? And then within each energy level, there's a certain number of electrons that fit. So in the first energy level, you can fit 2 electrons. So that's why you have these red dots right here. That's 2. Now that energy level is full. Once the energy level is full, we then move to the second energy level, which can hold a total of 8. And so you see right here, 1, 2, 3, 4, and there's 2 at each spot, so that's a total of 8. So that energy level is full. So then for aluminum, we go to the last energy level, and you'll see 1, 2, 3. That's it. There's no electrons left. So there's only 3 in aluminum, but the third energy level also can hold 8. So this third energy level, not full. Okay? So for this particular diagram of aluminum, this third energy level is not full. However, it is still the valence shell, and that means that the valence shell of aluminum has 3 electrons. And since the valence shell of aluminum has 3 electrons, that will give it certain properties. But the only way we know that the valence shell has 3 electrons is because we fill the first shell with 2, and then we go, oh, well, I have 13 minus 2. Okay, so now I go to the next shell. The next shell holds 8. So 13 minus 2 is 11. So I take away 8. Okay, so we still have some left. And there's 3 left. So 3 left will go in the next shell, and it doesn't fill the next shell. So that's how I know how many valence electrons aluminum has. So let's just do a couple of examples. We'll grab chlorine, okay? So here we'll do chlorine. So chlorine has 17 protons and 18 neutrons. So typically when you're doing the Bohr model, you write the protons and the neutrons in the middle. So if chlorine has 17 protons, that means that chlorine has 17 electrons to start with. So now what I need to do is start placing the electrons. So I am going to place 1 electron and 2 electrons in the first energy level. So I take away 2. That leaves me with 15. Now the next energy level can hold 8. So I'm going to take away 8. And that leaves me with 7. So let me put the 8. 1, 2, 3, 4, 5, 6, 7, 8. So I put my 8. Now I have 7 left. Now, the next energy level also holds 8, so I will not fill it. But I'll do 1, 2, 3, 4, 5, 6, 7. So there are 7 electrons in that last energy level, all right? So it's not full. But, this is important, this is the valence. And in this case, the valence has 1, 2, 3, 4, 5, 6, 7 electrons. And that fact that the valence has 7 electrons is going to give chlorine very specific properties. So let's do another one. All right, so we wanted to do another one, right? So let's do sodium. Okay, so sodium has 11 protons and 12 neutrons. So again, I just write those in the middle. Now, if sodium has 11 protons, that means that sodium has 11 electrons. So we're going to put 2 in the first level. It's going to leave me with 9. 1, 2, okay. So the next level holds 8. So I can take 8 away. It's going to leave me with 1. 1, 2, 3, 4, 5, 6, 7, 8. And then I got 1 left, so I put it there. So again, here I have the outer shell only has 1. It's not full, but it is still its valence. And in this case, sodium has 1 electron in the valence shell. And that's going to give sodium unique properties. So over here, we can do a couple more examples. I think I would like to do helium. All right. Helium's kind of a special one. Helium has 2 protons, 2 neutrons. So again, I write those in the middle. If it has 2 protons, it has 2 electrons. All right. So that means 1, 2. And that's it. That means in this case, that's the valence shell. And the valence shell has 2 electrons. But this valence shell is full because that first energy level only holds 2 electrons. Let's do another example. Let's just go with lithium. Okay, so lithium has 3 protons and 4 neutrons. So if it has 3 protons, that means it has 3 electrons. So I go ahead, I put 1, I put 2. That leaves me with 1, so I just put that in the next energy level. Now here, this is the valence shell. And the valence shell has 1 electron, which is going to give lithium unique properties. When the valence shell is full, that's also going to give an atom unique properties. And so the real key with the Bohr diagram is just understanding that the energy levels hold 2, then 8, then 8, and using that to know where to place the electrons. And you always place from the inside out. Now, there's another type of diagram called a Lewis dot structure. All right. So a Lewis dot structure is different than the Bohr model because you just use the element, symbol, and the valence electrons. So let's actually take a look back at some of our previous examples. So here I have chlorine. Now, for my Bohr model, I drew the proteins, the protons, the neutrons. I filled in dots for every electron all the way up to the valence shell. For a Lewis dot structure for chlorine, I would simply do this. I would write the element symbol, and I would imagine that there is a box around the atom. And I would write 1, 2, 3, 4, 5, 6, 7. I put 7 dots around chlorine because if you look here, chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. And so when you do Lewis dot structures, you just write the symbol and the valence electrons. So you would actually write this like that. You don't actually draw the dotted lines. But you do imagine that there's a box around it. You always put one dot on each side of the box until you run out of dots. Let's do another example. So on the previous page, we did sodium. Now, over here, sodium, we wrote its protons, we wrote its neutrons, then we drew the 2 electrons in the inner shell, and then the 8 electrons in the second shell, and then the 1 in the third. When doing a Lewis dot structure, I simply write the symbol for sodium and place 1 dot. Using our examples again, here I have helium. So I would do helium, and then I would do 1, 2. Because you'll note helium has 1, 2 electrons in the outermost shell. Then I also had lithium, so I would write the symbol for lithium, and then I would do 1, 2, 3. Because lithium has 1, 2, 3. That's not right. I don't do that. For lithium, see, this is the mistake I don't want you to make when you do Lewis dot structures. I just wrote lithium and drew all 3 electrons. You don't do that. All you do is draw the valence electrons. So lithium actually only gets 1. Take a look over here. These 2 electrons, right here and right here, are not in the valence shell. So when I drew them, it was incorrect. It is actually only this electron that is in the valence shell. So I'm only drawing 1 for that particular Lewis dot structure. Lewis dot structures are much easier. They're much quicker. That's actually why we use them. And the lesson here is that the valence shell is the most important. Okay? It's the valence electron shell that gives an atom many of its properties. And so the reason we can use Lewis dot structures is because that is the most important electron shell. All right, that's Bohr models and Lewis dot structures.